Okay, so let's move on to our next speaker, who is Louise Chisholm, who's from UCL and is the Joint Director of the UK SKA Regional Centre. Can talk to us about some of their activities.
So thank you, John and Joe, for inviting me here today. So I'm here to talk to you about the UK Square Kilometre Array Regional Centre and how we're developing this. The project started in January 2023, and so the Square Kilometre Array is developing a research facility that will transform radio astronomy by creating a facility that's more sensitive and has a wider range of frequencies that can detect basically radio waves that are happening in the early universe. The scale of the SKA, it's had 2 billion euros investment as of 2021, and it will enable a wide range of science. The telescope arrays are being developed in South Africa and Australia, and the headquarters are based in Manchester in Jodrell Bank. So the UK Square Kilometre Array Regional Centre, we have 2 key activities. One is developing UK infrastructure and services that will support and facilitate UK science. And also at the same time, we're contributing to the development of the global SRC network that will enable the research to happen and exploit the SKA data. And we're a collaboration of 7 universities. So our aim is to maximise the UK's return on its investment into SKO and deliver on sort of 3 strategic pillars that we have. Our teams are working towards both the national and SRCnet activities. They're working as part of the Scaled Agile framework, and this is sort of the internal sort of governance approach to sort of determining what work is done on an international scale, coordinating across 17 teams within the SRCnet and 16 countries. Within the UK, we have some nationally based teams, which are composed of people based in the UK, as well as people who are fully embedded within international teams, and also working towards the same goals. The Global SKA Regional Centre Network is a key part of the SKA. So it's the workflow is people apply for time on the telescope so they can observe what it's like the part of the sky that they want to. Then there's data processing close to the telescope to prepare the data and the data products, which are then delivered via the SRC net to the researchers. And so we provide the capabilities for analysis and also the science data archive. So without the SRC net, we won't be able to analyze the data from the SKA. The UK is the single biggest partner. We contribute at a rate that is commensurate with the amount that the UK has invested in SKA construction. And so this is approximately 20% of effort and infrastructure and facilities and services. So this collaboration of 16 partners is obviously in the highlighted in the map. So approximately each of the colours are approximately 20% of the amount of contributions. Canada's a bit less. And so it's coordinating basically the activities across the different partners. One of the challenging things that we've found is that the SRCs are outside the SKO cost book, and so they're funded, the money goes to SKO and is distributed and managed centrally. Meanwhile, the SRCnet has 16 different national research councils and that approach to things as well. So there's to manage this, there's a formal pledging mechanism and through the resource board. And so they assess what the work is and how much work is needed and whether there's resources available to enable this to happen. And the SRCnet is needed because there's just too much data for one country to manage. And the federation, John was speaking about what federation means for him. For us, it's a federation of sites, data and services. Also with a focus on authentication and identity management. And Jens will be talking tomorrow about that aspect. Providing a portal, delivering data products and then archive. And so this is the workflow there. So it's also providing the glue to each of these different nodes, and the different nodes could have a different specialism or a different focus of things. And so we are developing the SRCnet in line with construction of the telescopes, And so the science verification activity is going to provide an end-to-end test from capturing the data from the telescopes through to providing science out to the users. And so this will be starting in 2026. And so this is why we're focusing on developing our minimum viable product to enable this to happen in a global way at the moment. And as time goes on, as the telescopes, the arrays become are extended, we're also extending the features and scaling out the capacity for the SRC-net as well. So some of the challenges that we face is that the SKA is going to be have last over a long time. So we've got to be interoperable over 30 years to be able to evolve as technology develops. We also want to be not just astronomy for radio astronomers, but also enable multi-wave astronomy. So it's looking at gravitational waves, optical or other ways to explore the universe. And we need to be heterogeneous because everyone is building on their own national DRI capabilities across the world. So some sites are developing this as a greenfield thing and buying new compute, and that is great in a similar way that Isambard AI has started from the beginning. Others are building on very locked down systems, and that's proving that their challenges. And so each site has their own different challenges based on this. The SKA will be, and also these resources, we pledged into a global federated pool. And so this is going to be a policy challenge more than a technical challenge necessarily on what resources we can access, given that we are in a globally interesting phase at the moment. And also the approach that the SKA is taking is that users will not be able to download their data. So this will change the way that astronomers approach their research. They're used to downloading all the raw visibilities and doing the correlations step by step, and they will just be accessing through a sort of like a Jupyter notebook type of thing. I'll show you more about that later. So for our initial prototyping, the aim is to have 4 deployed sites that can provide the engineering prototype, and so mainly focusing on data ingestion, discovery, movement activities. And so we've got 8 sites that are currently developing the activities and deploying sort of the services. And so Spain has been the first one that's fully deployed and got the certificate from sort of SRC-net architect, and others are close by. So the software stack is using like an array of different capabilities. Some are using tools that are existing, and others are developing new capabilities to enable so like the flow through the data, to flow through the system, but also to enable, we've got these sort of like global services for data management, data movement and authentication, but each node individually will have to deploy their own services as well. And if you want to find out more about this software, we've got the link. So within UK, so RAL is our site that is physically ingesting the data and is developing the storage for SRC-net 0.1. And teams from RAL, Cambridge and Manchester and Stack HPC have been contributing to the deployment of the software activities. And we've also been, across the SRC-net, we've also been developing how we can develop the monitoring of these services and as well. So as the software stack demo, just to show some of the tools that we have, like the Science Gateway enables people to explore what's happening after people have logged on through the SKA IAM prototype, which is being based on the Iris IAM and similar, as well as being able to search for data through the TAP service to identify what is possible. And then there's also possible to like analyze things further using Carter, which is a software that's used with other observatories as well. So the next steps are to look at data movement campaigns across the network, and then also to develop the SRC-net 0.2, 0.3. And this is when the initial scientists from outside the community, outside the SRC-net network, and astronomers a bit further afield will be able to participate, and will be testing this end-to-end services. So as you may have noticed, we're developing our compute services and our federation to analyse the data before the telescopes have actually been constructed. And so they are in progress and being constructed at the moment, which is great. However, that does prove a challenge in trying to make sure we're sure that we're developing the right thing as we go. And so one of the ways that we're doing this is to support the astronomy community to maximise and develop new ways to analyse the data for SKA precursors and Pathfinder telescopes as well. And so they also have very large data challenges as well. And they're also improving and the sensitivities of their telescopes as well. So it's going to increase the data challenges for them. So it's looking for opportunities to support those communities at the same time. And so, so this change in the way of working with the larger volumes of data, changing of how the data will be analysed and shared, and also how it's not just a technical challenge, it's also a cultural challenge. And so we've been working with colleagues in the UCL Knowledge Lab and to understand how that impacts them. And so do people feel as though they're still an astronomer if they don't actually do all the steps? How does that affect their professional identity and their agency in developing and the way that they feel that they are as astronomer? And so this is about supporting new career pathways, recognising new ways of working, and also recognising the sacrifices people need to make to adopt a new infrastructure. And so this is true for sort of the SKA, which is a very large, new, sort of quite a radically different type of radio astronomy research infrastructure, digital infrastructure that's combined end to end. But equally, when people are adopting fair data sharing principles or moving from I'm used to my digital infrastructure and it serves my research community, and that's the one thing to think about. It's also a change there. And so it's being realistic about what people are gaining, what people have to sacrifice, and the time that people have to do, develop metadata and how that needs to be valued and those lines. And so we've been, Francisco's done an ethnography study looking at understanding what's observed, and then the thematic analysis identified key social science concepts, and those can be used as a starting point to understand and unpick a bit more about what the next step could be, rather than just saying, everyone said no, I don't want to. And so it's providing a route through that by giving new ideas and new concepts as well. And so we are using this within the UK SRC to inform how we're supporting the UK community. The SRC-Network will provide user support services, but to achieve our mission to maximise the return on SKA investment in SKAO, we're looking to what ways we can maximise this and develop this further. And one of these is developing our science user support services and community engagement activities to help people adopt to the new ways of working, also to prepare them with having tools and workflows that they can adopt, transfer in, but that are also useful now for the Pathfinder and precursor telescopes. And so we've been running a demonstrator case scheme, which these were identified during the proposal phase in 2022. And the approach we used there, it might be interesting for other communities as well, because it was helping people to think through the different steps on what is needed for the communities. And some of the groups whipped through the exercise in 5 minutes, and others, after an hour of discussion, were still needing more support and help in that. And so that might be something to share. It's on the Zenodo page for our resources are there. And so these demonstrator cases are developing tools and to help the researchers who are currently, most of them are currently embedded in the project, but some are also external users who were part of the proposal development process and those workshops. And these are developing tools, but also enabled us to develop science leadership opportunities and take up as the SKA SRC-Net is developing its science delivery workstream alongside there. So in the future, we're currently developing our processes and approach for extending the demonstrator cases and early adopter projects to have an external call for new projects And so that will also help inform the development of the UK SRC, as well as providing opportunities for them to have tools ready for their research. And so in summary, we're developing infrastructure and services for radio astronomy in an exabyte era, and through providing better data access and curation, software tools and analysis, better support training and careers, and with the aim that it will maximise our return on investment, the SKA. Thank you. And everyone else did all the work.
Great, thank you, Louise. Questions for Louise?
Thank you very much for that. So, being an ex-astronomer, this would be a big cultural change. I like the idea of using a standardized workflow to process the data. I think that's a really good idea. But how do you then address the opportunity to use new techniques? So is there a means of accessing the data without going through the standard workflow?
So there's, okay, so is it point? Yes. So for this step here, you have the the data capture, and then it's these two steps here: the signal, the central signal processor, the science data processor, which will develop the observatory level data products, and these will be based on the observatory level data products will be based on what the application was for the observing application in the first place. And as part of the SRC net, there will be opportunities to add in workflows and have templates of workflows there. And I think that is.
So the intention is you would put the development workflow into SRC net. You still wouldn't access, the data would still reside within SRC.
The access will reside in the SRC net. So the observatory level workflows will be the starting point for the research, and then from that you develop the advanced data products, and for the research to sort of happen on as well. So it's.
Hi, thanks very much. Chris Cole from Dundee. I'm not in this field at all, but I was curious about actually a very similar question to this about at what level do you standardize the data? Is the data as captured, is it standardized or is it a hodgepodge? I mean, I come from a community where all the data is non-standardized at all. So trying to standardize data is really difficult. And then a follow-up question is around, you're talking about data discovery. Can you talk a little bit about that, how you researchers come in and discover data? So
in astronomy, they have the IVOA is an international organization that supports the metadata development, and so there's work groups within that. That organization's been running for about 20 years, and so that helps standardize the workflows. It's helped with collaborations and astronomy projects that bring together multiple radio astronomy facilities. We have two telescopes facilities basically that will be capturing data. So in that sense, there is restrictions amongst there. However, the data discovery side of it is still being developed. The metadata work is one of, and the discovery side of it is still being developed. We've got the sort of initial approaches that we can test, and very early technical, can we find data is the question. It's not about what data yet. And it's just, can we do it? And so that's where we are, but there are work streams on developing metadata and aspects for that as well.
Could I come to the question about access? So in some of the communities, we have a lot of emphasis on co-participation and being able to kind of co-develop research. How do you define who has access to these systems and who doesn't? Is it about belonging to an institution? Is it about participating in certain research? I mean, I know this is very specialized, right? So he won't apply for all, but I'm just trying to generalize the problem.
So we've not, so part of it is to belong to the right country. So the SKA people who invested in SKA basically, and that's one side of it. There's other side of it is there's wanting to have SKA2 And so I don't know when that will be developed yet, but that involves countries in Africa as well, so beyond South Africa as well. But it's more about being part of the country, or having but the actual policies and everything like this is still to be defined.
And could I do another question? I saw somewhere in the services you provide, and I guess that goes about the developing specialized analytic tools. You support containers. So it is possible for the project to develop some software and then just look at the data that has been standardized with Access, right? So
these processes still need to be developed, but
that's the idea, right?
That's the idea.
Yeah, because
but
that's okay.
It's still being developed on how that would work exactly. And so, but there will be an open public archive as well, so people will be able to access all the data eventually.
Yeah. So no, I was, I mean, of course, this is really a massive project, and I was fascinated by the cultural side of the thing, and especially a term you used multiple times called sacrifice. And coming from a technology background, technology is so disruptive. But when I use modern technology and I change something, I do not necessarily think of it as a sacrifice. Yeah, most of the time. So could you just elaborate on this, like why you use, like why you think, because I'm odd, this is going to happen, and why there will be a sacrifice for people participating in this project? Yeah.
If people want to participate in this project, they have to sacrifice getting access to the raw visibilities that they can have access to from other telescope facilities. And so for some people are not, I was just looking for Richard, but he's not here. So some people would be, that's kind of an issue. Other times it's a sacrifice of time. So if you're looking to develop metadata or looking to do different practices that are needed to participate, and this is sort of the time takes to work out how to get your workflows to work on a GPU system instead of a CPU system. That time is lost, and and they might value instead spending time doing more research, and so they won't make it a fair workflow. They won't want to upload it into the SRC-Net. They'll wait for things to mature a bit further before engaging. And so would they be interested in developing the workflows and making them fair, and whatever the policy requirements are for the SRC-Net to use them within the SRC-Net system, or would they rather wait for other people to do that work and then they can tweak things later on? It depends on what their values are and how they want to spend their time, or what's valued for promotions and all of these types of things.
Just another point. Sorry, when you mentioned sacrifice, so being involved in this project from the beginning, HPC centres, national centres that want to come into that federation may have to sacrifice legacy ways of thinking, because of course we are all mired by our legacy, and the larger the national centre, the more legacy baggage it carries with it. Yeah, so we may need to sacrifice legacy to gain functionality and have a core element of functionality that members of the federation have to have, allowing some kind of technical freedom. But sacrificing legacy, I think, is the main one.
Yeah.
Jeremy?
Yeah, I think the sacrifice, which is kind of dying to allow new growth. It is Ash Wednesday, so I can say that. As Louise and Sean was saying earlier, it's the loss of control. So you have to use other people's things. You can't look at the source anymore. And it gets worse because we've got a laptop culture where things are on your laptop, and that ends as well. Okay. So it's that loss of control and having to rely on other people. But I also think the other thing is the other C word. You're going to have to comply. you're going to have to comply. It's compliance as well. So it's loss of control. You've got to dump the legacy, as Paul says. But you're also going to have to comply. And that's very hard. Right.
Excellent. Glad you're on this slide, because this slide intrigued me. So I know a little about SKA and the data format in terms of the data cubes, but you say on here you want interoperability with multi-wavelength astronomy, which doesn't use these data cubes. So for instance, FITS format files, I presume the other radio astronomers are still using some sort of APES++ type format, going back to my days. How are you going to achieve this consensus on how you make the data interoperable between the different wave bands?
So I'm going to go back to the first slide. So Rob and Jack are the astronomers, and so unless Ian has a no, and we don't have Richard.
I was going to say, grab Richard.
Yeah, Richard might have a better answer. I will defer to astronomers rather than that. But people, this is the intention, and what people would like to work out how we do. Having ambitious goals is what started this project.
Yeah, I remember in my master's doing multi-frequency observations of active galactic nuclei from radio all the way to X-ray, and joining the data together was a complete nightmare.